There we go. So now let's wait for everyone to pour in.
Hope anyone comes in.
We had about, I think we have 30 signed up. Pretty good odds, Paulo.
Well, if not, we record it and we have this.
Exactly. I mean, honestly, this is a PLAYINAR we've needed, a webinar video we've needed for a very long time. So, I mean, we benefit either way. And it kind of lit a fire. Hi, Christine. Hello.
Hello, Christine.
Good morning to you. Tell us how you're doing. It's quite exciting, actually, because, you know, I know, Kristen, you've been requesting flow programming for quite a while now. So here it is. Me too.
Yeah, super excited.
Actually, to be honest, I bet Paulo is just as excited as you, Christine. Paulo, earlier when we were doing a practice session, he was like, I'm so fired up. I'm so excited. And it's not just the caffeine from the tea.
No, there's a lot of interesting stuff today that I really want to share with you guys. And yeah, and flow programming is really special to me. I quite enjoy that way of thinking. So hopefully I can share a bit of what's inside my brain with you guys so you can also get excited as much as I do.
It's pretty pleasant actually having you know, our CTO here in the session and our CMO, Vivian. Hello. Hello.
Hello, Vivian. Are you in the classroom?
Exactly. Well, right back here is a massive mess. So I'm actually in my bedroom. So
your bedroom's a classroom? Oh, Paula, sounds like Christine was saying that you sparked her interest and she's very thankful to learn from you.
Oh, I'm glad to hear that. Super glad.
Yeah, it's really nice to, in a way, have the brain and the fingers, I should say, behind creating the tool, actually presenting the tool, like from a very deep pedagogical standpoint. I think sometimes it's something that, you know, internally we get to hear it, but it's really nice that we get to create this platform for you, Paulo, where we can present Paulo.
I'm gonna get shy like this.
Well, good. All right, so we'll get started in about 4 minutes. We opened the PLAYINAR a little earlier. We thought that'd be nice to have a little bit of a social session, but let us know in the chat how you're feeling, how you're doing. Hello, Anita. Hello, Isabel. Hello, William. How are you all? Let us know in the chat.
Lindsay, a quick question. Have you launched a live streaming on Facebook yet?
I have not.
Okay, because I'm not sure if I have the I'm able to facilitate that.
Okay, I can do it.
Mm-hmm.
William, I hope your son gets to play. Actually, I hope your son actually programs quite a bit with Quirkbot after this session. Yeah, Paulo, what do you think about like flow programming and Scratch? What's kind of like some of the strengths and challenges between the two?
Yeah, so they are very different paradigms, right? And in with blocks, right? So well, what is Scratch is based, we are really talking about instructions, telling things one at a time. You do this and do that and do that. The advantage of that is that it's something is a concept we are used to. Maybe a bit unfortunately, but we are used to following orders, right? So we really understand these sort of direct commands, right? There's a very simple thing with that. Yet, when you look around in the world and in the nature specifically, well, that's not how it operates, right? The nature is not obeying commands. Things are just happening, right? And I mean, it sounds even spiritual to talk about it like that, but everything is interconnected in nature, right? And the flow-based programming, this paradigm, it leverages on this concept that things are all interconnected, and it presents itself as a more suitable solution for some types of problems in computation, and and it's types of problems where you can't take time in consideration. You just need to think that something happens all the time. So you establish a rule that is like a general rule. And for those kinds of problems, it becomes much simpler to express that in flow-based programming, where if you would have to do things in instructions, it would be very cumbersome to do so. But the opposite is also true, where block programming, it's much more effective when you, well, I think a very good example is the if and else, right? If you're trying to sort of go a path and then decide, I'm gonna go here or here. It's a concept we call branching in code. The concept of branching is much easier to achieve with blocks than it is with flow. So it is a matter of what are you trying to achieve. The examples where flow is actually used sort of in the industry, let's say, we're talking about sort of music instruments or music synthesizers and creation of music digitally. We're talking about networking. So if you think of like the internet and how you have all these computers interconnected and you have to create rules between them, the flow is a way used to program those systems because they are complex and you can come into them from many perspectives. Computer vision and artificial intelligence, which usually is a high-level system, right? You have like you don't really know what's going on inside, but you're controlling these parameters. It's much more comfortable and much easier to express ideas in a flow-based paradigm than in a block-based one. But ultimately, and that's what I hope everybody gets to sort of, understand and embrace, is that there is no right or wrong. It's especially important to understand there are multiple paradigms and there are multiple ways to think about computation. And then sort of make your choice based on that. If we close this in a little bit to the world of Strawbees and the things you can do with it, I would say that flows allows you to build much more complex and interesting motion and things that are more lifelike, more organic. with flow programming than with block-based. So yeah, it's a very interesting thing. So I really hope, if you guys are not familiar with the concept at all, that you that you get to explore it a little bit and see, and maybe start seeing the world through those lenses, right? That's one of the cool things of programming. You get this like power lenses to look at the world and start breaking down problems in a computational way. And this is just becomes another sort of tool in your toolbox to decode the world.
It's a beautiful explanation, Paulo. Thank you for sharing that.
My pleasure.
So let's get ourselves started here. So thank you everyone for joining us for another session of Strawby's PLAYINAR. And we're really excited to participate in Hour of Code. So for those of you that maybe aren't familiar, because we have a very, Hour of Code is traditionally usually more well-known in the United States, but sometimes on a global scale, individuals might be participating in an event called Computer Science Week, which this year it's on December 7th through the December 13th, I believe. But you can always host computer science every day. So it doesn't have to be limited to just 1 week, but we're gonna start by doing 1 hour of code during this PLAYINAR session. So in this PLAYINAR session, we have our very special guest, but not really a guest. I get to work with him pretty much every day at Strawby's. His name is Paulo. Paulo, can you give us a brief introduction to what you do?
Yes, hey guys, I'm Paulo. I'm Strawby's CTO. And well, I'm the guy behind the tech stuff, right? The digital tech stuff. And I'm the person behind Strawby's code from the beginning, developing that idea and sort of bootstrapping this, how can we make programming more interesting and accessible for kids? And nowadays, developing the product and all the other digital products that we have at Strawby's. So I'm sort of the go-to person in terms of like how things work digitally. Mm-hmm. Yeah, I mean, I guess that put it in a nutshell.
Yeah, and a lot of the work you do, you are a developer, like through and through, but you also are someone that is helping demystify coding for children, for educators, teachers, makers. So you've actually had a very well-rounded experience, because you could easily be behind the code, but you choose to be in front and center.
No, absolutely. Code was so empowering to me that I take great pleasure in trying to empower other people with it. It opened up so many doors, and yeah, I want these doors to be just wide open for everyone.
Absolutely. So this PLAYINAR is a little bit different, where I'm going to actually be taking quite a bit of a step back, and Paulo is going to be our main contender for this entire session. But I will be doing a little bit of a demonstration with the new Quirkbot, the Quirkbot version of the Friendbot. So we had formerly previous PLAYINARs, we had a Friendbot that was using the microbit with the robotic inventions board. But this time we remixed it and made it into the Quirkbot edition using Flow. So we have a lot of really new tools to present, because we have a link that you can actually that we will send in the chat, that you can actually try the simulator with us and program with us and also give us feedback. So this tool is actually just being launched for the first time right now. So without,
it's being previewed right now.
Fair. It is being previewed right now.
Yeah, so, I mean, you guys are special. You're seeing something no one else seen.
Yeah, live, as Sam said. So if you have any questions, feel free to use the chat, also the Q&A feature that is below in the bottom of Zoom. So just let us know in the Q&A if you have questions, and we will reserve time at the end of this PLAYINAR to answer as many questions as possible. Of course, I may chime in and let Paulo know if there's a question that maybe is relevant to what he is doing that would make sense to implement it, but just know that we will try to save a lot of time at the end for questions. So without further ado, I want to hand it over to Paulo.
All right, let's get this started. Yeah, little special today. There's this big preview you guys gonna get access to, which is the Quirkbot Simulator, which is a feature that is being on the build for a very long time, actually, and I'm very happy that it's finally arriving its prime time. And it's a great opportunity for us to share it with you and gather some initial feedback, but also for you to be able to see the open potential that Strawberry's code now is getting. And in order to do that, we're going to be talking about flow programming. But even before going there, we are going to be talking about waves, which is a very, very cool concept. So let's get this started. I'm going to share my screen. Lindsay, I think you need to make me a host so I can share my screen.
There you are.
Yeah, and Lindsay had shared this link over there that you guys are free to try. As I said, it's a beta link. It's not gonna be up for very long, so it's really just for this session. And as anything that is beta, it may break, it may not work correctly. Please bear with us. So let's go. I'm going to share my screen, and let me kickstart this presentation. Do you see it in full screen?
Yes.
Lindsay can confirm. Okay, cool. So we're gonna be talking about waves. And waves are, I mean, they're just one of my favorite things. It's such an interesting thing, and it means so many things, right? When we talk about waves, we imagine waves in the ocean, but it's also this sort of very fundamental mathematical and physical concept that seems to operate everything in nature, right? And it gets to that philosophical level that, I mean, we don't really know if it's us trying to create a model of the world and we found waves a way to sort of fit things in, or if waves are actually fundamentally part of the world and we just sort of discover them. You know, so they are, if we talk about sort of light, there is the duality, right, of particle and wave duality. So, I mean, this is, we can talk about the waves for such a long time, and this is like a PhD material, right? And we're going to close this in a little bit. But, you know, for those that have been teaching math, or we might remember from us learning maths, we had things like sine and cosine waves, right? And this image is super simple. I just took it, I guess, from Wikipedia. And it's just showing like how a sine and cosine waves are formed based on the circle. So from here, we can already see that it's something very simple, that when we look at it from a different perspective, it becomes a wave. But next slide. Oops. The cool thing is that they are actually everywhere in nature, and we can start observing them. So you find them obviously on the waves in the sea. On this case, just on the wave reaching the sand. But you know, our classic waves of when you drop something in water, it ripples in waves. But to other things as well. So if you actually see the flight of a bird, the flapping of its wings, and you would sort of plot that movement in time, you would also get a wave. When we walk around, if you would plot how our wrists go up and down as we move our arms, we would have a wave. Even if you're trying to do an awesome karate move, well, you're going to do that if you actually nail that perfect wave. And things very fundamental. If you have a pendulum and you know, the only things acting here is gravity and time, you get a wave. If you would plot a plant folding and opening throughout the day, you would get a wave. So this concept that the world is based off waves that combine with other waves is a very powerful one. And I hope we can sort of embrace that and try to look how into programming we can approach this. So that was the end of these slides. It was just some warm up. And now please just confirm you see the screen, Lindsay, for me.
I do.
All right. So now we are going to talk about flow programming. So let's get this going. So when we talked about blocks before, you guys are familiar with it. We have one block that sort of gets stacked under each other. When we're talking about flow, it's a different way. So let's start like this. Flow, like the technicalities of what we're looking at. We have not blocks, but nodes. That's how we call them. And the nodes, you can never stack them one to another. So as you see, they're not really like, they don't click to each other. They're just free moving. You can put them wherever you want. And they always follow the same sort of pattern. They have these things on the left that we call them parameters, and they can have or not an outlet on the right. So that's sort of just technically what a node looks like. And it is possible to connect the outlet of a node to a parameter of another node. And that's it in terms of how you build programs. You have nodes and you connect them together. But let's talk a little bit about these nodes themselves. You're going to notice that we divide them into these three categories: input, brains, and output. And this way of categorizing the nodes is very useful when you start actually looking at the systems, the robots, the things you built, as systems that actually have a biological way to look at them, a biological frame. So I'm going to make a little parallel in here. So the things that we call a parallel between the Quirkbot and ourselves. So the things that we call inputs in the Quirkbot world are sensors, right? So we have a circuit touch sensor, and we have a light sensor, and we have other ones that are advanced, but sensors. And on ourselves, if you would think that we are a robot, our eyes are the sensors, our ears are sensors. So they get information from the world into the system. Okay, that's an input. And on the opposite side of that, we have outputs. So the job of the output is to get an information that is inside the system and get it out into the world, right? And for the Quirkbot, we have things like the LED that emits light into the world, and we have the servo motor that makes movement into the world. And if we were to think about ourselves, well, my voice is an output. I'm outputting it to you guys. My arms, I can move them. So these are outputs. And then we have the brains, right? Which is a more interesting, different concept. So brains are things that, well, by themselves, they don't interact with the world. They're just happening inside, right? And in the Quirkbot world, these are usually things that are generators, like the wave that we're going to talk about. They sort of produce a number that then you can do something with that number. Or they can do things like signal processing. You can combine multiple things, multiple multiple numbers into another number, or you can create a list of things, or you can find the average between things. So they're just processing. And if we compare that with us, well, this is our mind, right? I mean, we can be sitting here just thinking wonderful things and not sharing that with the world, right? So, and if I want to share something, I need to connect it with an output, like my voice, right? I'm having thoughts and I'm outputting them to your world. So that's the way to look at the nodes. And you build your program by combining inputs, brains, and outputs, right? And okay, so let's look at this. Let's look at an input, and now, drum roll, I present to you the Quirkbot Simulator, which is docked here to the right of my screen. I'm even going to start from scratch. I'm going to delete this. So the Quirkbot Simulator looks like a Quirkbot over there. Nothing happening right now. This actually works with all modes of programming. It's not just for flow. And the moment I drag a node into here, some stuff starts to happen. First, I got a warning there. It's telling me circuit touch is disconnected. And the reason for that is that, well, every time I have an input or an output that have a physical counterpart in the world, I need to tell, well, where is that sensor? The circuit touch can be in any of the arms and legs or the horn or of the Quirkbot. So I'm going to just select the horn here, so we can see that warning disappeared. And now we have this like indicator that there's like something happening here on the horn. And if I go with my mouse, it changes color. So this represents now that, well, the horn is active. I can touch it and it's going to do something or detect something. The other thing in the simulator is this little area, this box over here. This is a graph, a time series graph. And what it's doing, it's representing what is the current value of this circuit touch. So let's just see stuff. I'm going to click here. And you see that once I click on the horn, this number is, there is a number here that is going from 0 to 1. And this line is jumping between 0 and 1. There is two numbers here, a small and a bigger one, representing a minimum and a maximum, right? And this actually matches these two parameters that we have on the node, minimum and a maximum. So that's how this basic display works. If I'm not touching the sensor, it outputs 0. If I'm touching it, it outputs 1. All right, so if I have a program with only an input, it's not an interesting program, right? Because I can't see what I'm doing. There's nothing coming out to the world. It's only information going in. So I need an output in order to make something. Same way, the LED is disconnected. I need to decide where this LED is. And the LED block, you can use it to control the built-in LEDs in the board, the eyes or the mouth, or external LEDs. So I'm going to go for external one, like a LED on the left arm. And OK, so here we have that LED. And you're going to notice that the LED has this light intensity parameter. And this one, it's a number that can go from 1 to 0. And if you notice what is happening there on the right, while I'm dragging this, I am changing the amount of light that that LED is emitting, right? So that's it. LED is between 0 and 1. It's going to display some light. OK, so now I have an output, I have an input, but they are disconnected. So here comes the flow of information between these two nodes. So I'm going to connect the outlet to the light intensity. So now, if I touch the horn, the light turns on. Okay? And the interesting thing with flow is that, well, we can now start combining these things. Let's say, well, why just one LED when I can have two? I want to have another one. And this one, I'm going to connect it to the left arm. Uh-oh, the left arm. Now I got an error. It's a different message, right? And it's saying that left arm has more than one component. That is, I'm trying to drive two LEDs that are on the same place. So this is not going to function correctly. So I just should go for the right arm. Great. So now I have two LEDs. And with one outlet, I can actually control multiple parameters. So now I have one circuit touch that is controlling two LEDs. Great. And this would work for any other output. So if I bring a servo motor in here, that is, you see that the layout of the node is very similar to the LED. It has, instead of light, it has a position, and it also has a place. And in this case, I can be servo 1 or 2, because you can connect only 2 servos to the Quirkbot. And the same way, I can control the position of the servo. And forgive this flash that the image sometimes gives. This is why this is not released yet. Some quirks to iron out. But the same way, I could now use that circuit touch to drive the LEDs and the servo between 0 and 1, 0 and 1, 0 and 1. And okay, so let's say, yeah, this is fine. I'm happy with the sort of this interaction, but this motor is moving too much. I want the motor to move just a little bit. So that's when you start using the minimum and the maximum. So maybe instead of 0 and 1, I want it actually to move between 0.5 and 1, so half the motion. So you're going to see that now the LEDs are actually on when I'm not touching it, but they're dimmed. They're not on their full brightness. And the servo is on the middle position. And if I touch it, it's going to go all the way to the end. Okay, so, okay, cool. We made a program with input and output, but that's just it, right? So if I don't give any input to it, it's not going to do anything for me. So here enter the brains for us to start doing things that sort of happen on their own. And here comes the waves. I'm going to delete one LED now, just now that I showed it to you, just so we have a bit less clutter on the screen. And I'm going to bring a wave node. And the wave node, sorry, I just pressed something wrong on my screen here and something popped up. The wave node, it has a few different parameters, but let's start with actually just looking what happened on the screen. And I'm going to delete actually most. I'm going to just leave, actually, I'm just going to leave one LED visible, so it's a little bit easier to see. When I drag this wave in here, that box that we've seen before with the circuit touch became a new one. It's a green one, matching the icon of the wave. And now this is showing this, surprise, surprise, a wave, right? That is oscillating between 0 and 1, which is matching the minimum and the maximum over here. And if you notice, this wave is quite smooth, like it's a smooth curve. That is because this is a sine wave. Well, we can change the type of that wave. So let's do that and see what happens. We can have a triangle wave. So a triangle wave, it's similar to a sine wave in the sense that it smoothly goes from one point to the other, but it doesn't have those round corners, right? So it's more like a constant speed of movement. Actually, a nice way to do this is to put the two of them together. So then you can actually see the difference between them. So let's explore a bit more here. We can also have a square wave. And well, so a square wave, as you can see, it's very sharp, right? It goes from 0 to 1 immediately, then back to 0, then back to 1. And well, let's not just look at this graph. I'm going to plug this wave to the LED over here. And so we can actually see the difference that it creates. And I'll go quickly back to the sine wave so you can see. You know what? I'm going to have two running in parallel. Oh my God, I'm so excited with this simulator. It allows me to do so many things at the same time.
We love it.
I'm truly excited. Let's do it like that. And now, okay, so both of them are sine waves. I can change one to triangle. It's a bit hard to see the difference. But if I change to a square, it becomes quite obvious the difference they do in the movement, right? And let's keep exploring. We can have a pulse. And a pulse, it's like a square wave, but shorter. So instead of being a full square, it is like a quick pulse. And you can see the difference between the two of them. And then you have things like a ramp up. And what the ramp up does, it's the top here. It slowly grows to a number and then back to the original one immediately. So it looks like a sawtooth, the wave. That's actually a name of wave, the sawtooth wave. And it's because it has a shape like that. This is used everywhere in electronics. Well, we already know waves are everywhere, right? And we also have the ramp down, which it reaches the value immediately, and it slowly goes back to the original. And this reminds me of how a heart pulsates, where the blood sort of gets pushed quickly, and then the muscle, or it contracts, then slowly relax, contract, slowly relax. Yeah, so these are the waves. And now we can start. Let's remove one here for clarity. Well, we can start playing with this. Let's go back to the sine wave. I really like it because it's so smooth. And well, we can modify the length of the wave. And this is a length in seconds that determines how long the wave takes to repeat itself. It's a periodic wave. Now it's 1 second, so it's pulsing every 1 second. I could change that to, let's say, 3. So now it's going to be slower. And you can see down here that the graph became wider, right? Or I can make it short. Let's put it 0.4. So now it's moving really, really quick, and we can see immediately the difference in the graph down here. And well, the same way I was controlling LED, I obviously then can use that to control motor, right? I'm gonna put it a little longer movement so it's a bit more pleasing. So now we have an LED that is moving in sync with the servo. And there's something interesting here to talk about. I'm going to change to the square wave. So when we change to the square wave, you can see that the LED, it's either on or off, like binary, on, off, on, off, on, off. But the servo is still sort of moving a little bit smoothly, right? Why is that? Well, the reason is because the servo doesn't move at the speed of light, right? It has its own inherent speed, and it has a maximum speed that it can move. So it's basically trying to catch up with 1, catch up with 0, catch up with 1, catch up with 0. That's why you have this sort of difference in the output from the same signal. Yes, so that gives a little more perspective into the nodes, into the wave. And well, you can start getting quite advanced with this, and I'm going to show this as a curiosity level, because I don't expect you guys to start playing with this from the start, but you can combine waves together to create even more complex waves. So now we have a wave with a 1 second length, and what I'm going to do is, like, imagine I want this LED to sort of blink with this speed, 1 second, but then I want it to like speed up, and then I want it to slow down, and then speed up again, right? So I need to modulate, and that's a term, wave modulation. I need to modulate the length of the wave in between a short period and a long one. And for that, I'm going to use the secondary wave. So let's say I want to modulate this wave between 0.5 period and 2 seconds period. And I want to do that over the course of 10 seconds. So throughout 10 seconds, I'm going to change the speed of this wave. So now look what happens here. The LED is slow, and then starts to speed up. It's very quick, it's very quick, it's very quick, and then slows down again. And when you see the graph, you can clearly see when this line is down, the LED moves quick. When this line is up, the LED moves slowly. So I hope this was a good sort of introduction to the world of waves. As everything else, you will only get this really once you start using it, right? And having your own problems and your own ideas to solve, which is what Lindsay is going to hopefully give you a good sort of activity to try this out. But just before I go and give this away for Lindsay to speak a little more, I'm just going to show you some other things that are hidden in here that are interesting. Well, the randomizer. The randomizer, we can think about it sort of like a wave, or better, I mean, we can think it as a generator, just like the wave. So if the job of the wave node is to create a number that is oscillating between two numbers, the job of the randomizer is to create random numbers. So if I look at the graph of the randomizer, there is no pattern to it. It's just random jumping between 0 and 1. And I can change and it has an interval parameter. And this interval determines what is the frequency that it emits a new random number. And right now it's half a second. And if I would, I think the randomizer is nice to see with the servo. So now the servo is every half a second moving to a random position. And I could change this interval to like 2 seconds. So now every 2 seconds, the servo is going to move to a random position. Or I could make that really short, let's say 0.2. So now the servo is just like, just moving randomly, sort of in a shaking kind of behavior that can actually be quite interesting if you're trying to create something that is, that looks like it's confused or doesn't know where to go. But okay, that's it for now. I mean, there's much more to explore in the flow world, but it's not the 2 hours of code. It's just 1 hour of code, and I need to refrain myself from talking too much.
Well, could you show us the text preview? We have a question about that, just transferring the flow program to text. Someone asked about that.
Absolutely. Let me do this over here. So the text preview, like both, let me backtrack a little bit. Both the blocks and the flow-based programming, this is not what the Quirkbot like natively needs in order to create a program. The Quirkbot will always speak text, right? It's more complex than that. It speaks bytecode, but that's a sufficient level of, forgot the word. But so every time we make a flow program, it will generate a piece of text. And actually, because the Quirkbot was actually developed, I mean, the first thing we did was the flow, right? That was the core of the language. The flow actually maps to a very clean and maps in a one-to-one way with the text, which is quite nice because this code is very, very readable. So what we have in here is, well, we declare two instances and they represent the nodes. One of the randomizer and one of the servo motor. Then we configure the randomizer. We are setting those parameters that you saw me doing with my mouse. That's the interval of the randomizer. That's the minimum of the randomizer. And then we configure the servo motor. So let's skip the first line for a second. So the second line here is the place. So I'm telling, okay, go to servo motor 1. And then that's the magical bit or the interesting bit. There's no magic here, only technology. We have the position of the servo connected. So we call the connect function to the out of the randomizer. So that's how you establish the connection between them. So you see that this program here, for those familiar with Arduino, this is Arduino. Maybe I should have explained that from the start. Now we're looking at C++ code that is Arduino compatible. So for those familiar, we have the same signature where we include a library and we have a setup function that runs once when the program starts. And then we have a loop function that repeats itself. So you're going to see that there is nothing in the loop because flow, we just describe our program. We don't need to keep telling it what to do. We just describe it and then it does its thing. If we would look at a block-based programming, and I can do a quick one here, we'll see that it looks way, way different. And since we now have the possibility of having these multiple entry points for the blocks, like the multiple events, the code looks quite more involved. And that actually talks a bit with what I told you guys earlier, like how certain languages solve certain problems. Because of the architecture of how the Quirkbot works, describing a block-based code that has multiple events actually requires quite a bit of code and of text code to do that. So the flow provides a sort of simpler. And if you're curious, you could always create a program in flow or in blocks, and you could, when you preview the output, you could actually open this in the text editor. So now I'm out of the visual world, and now this is only happening by the code I write, right? So I can set the minimum to be 0.5. So now it shines a little less, and so on. Okay. All right, then Lindsay, take it away.
Excellent. Thank you, Paulo, for the very thorough responses. I definitely see the chat as very proactive with a lot of great questions. And actually, we have a few questions already lined up for the Q&A.
Great.
So I just want to show, our little friend here. So I'm going to do just a really short demonstration to kind of apply these really great concepts that this big blue sky thinking when it comes to waves, but also applying it in programming that he has already demonstrated. And also, applying it to the physical world, which is kind of like the strength of the Strawbees connectors. But now you have multiple ways to program, not only with just the physical computing side, which we always encourage, but also in the simulator. So I have made a Friendbot example. So you may have seen in previous PLAYINARs that we had a Friendbot that was using the microbit, using the robotic inventions board. So we made another iteration of it where we are using the circuit touch. So, and we're also using, using the waves as a way to program. So I've actually pre-made our little Friendbot here. So we have the circuit touch function using the 2 alligator clips. So I have one of the inputs as touching the horn of the Quirkbot here. And I also have a servo motor that is controlling our little robot friend's head, just to kind of show some basic, you know, physical expression. So I can make my robot really excited. I can make them very upset or angry. So we're just going to kind of play with the waves. And also we're going to be using these small LEDs. So I took a few LEDs and placed them on the arms, so the left and right arm of the Quirkbot. So, you know, Paulo, maybe you can, maybe we could do some pair programming, which I think is a really fun thing we want to always encourage in the classroom anyways. What do you say?
Yeah, I love pair programming. Let's do it.
Okay. So, you know, I won't really explain my code too thoroughly, but, you know, so I think maybe, Paula, I want to start with maybe lighting up the LEDs. And, you know, what I was really inspired by earlier was maybe trying to do like a heartbeat, because I think I heard you mention something about using one of the waves to kind of try to mimic some sort of heartbeat. So I think you even said like it was the ramp down, was it?
Yeah, sure, exactly. Because the heart has this behavior, right? It sort of quickly pumps and then relax, quickly pumps, then relax. It's more complex than that as anything, but we can simplify it like that. So yeah, if you get the wave there and connect to the 2 LEDs and then make sure to place them somewhere.
Okay, so the left arm and the right arms I will use.
Yeah, I mean, this already looks hearty to me.
Hearty, great pun.
Yeah.
So, you know, I'm trying to also think about that. I want to use this circuit touch in a really interesting way. And, you know, I think I want to grab the Friendbot. So maybe like I'm pinching the hands and completing the circuit. So one hand is the ground and one is the button to trigger. So using circuit touch, I'm completing the circuit and I'm completing some sort of basic interaction. So do you think my robot should be excited or calm at first? What like a
yeah,
what
well,
should we
I
do?
mean, I think this we can think of a interaction that maybe the robot is you know, it's there, it's very calm, chilling. And then when you come and you touch it, it becomes happy to see you, happy to so I think let's scaffold this program, right? So okay, it needs to move, so we're gonna need the output, and that's the servo motor. So you bring the servo motor in there, and then you pick 1 or 2. I don't know which one you connected in your.
It's 1 in this case.
All right, and well, we want this robot to move on its own, right? So first we want it to be moving calmly. So leave the circuit touch for now and bring in the wave into the scene. Our one and only wave. And well, plug it into the position so we get some visuals going. So if we look at the movement of the motor and just imagine that this is the head of our robot, it's not too chilled, right? It's kind of moving a bit too fast. So let's find a length that represents a calm movement. So maybe instead of 1 there, try 4. Sorry, on the length, on the length of the wave. Yes, because this represents the duration of the wave, right?
Right.
So, okay, so now see, the motor is moving slowly. And if we would sort of imagine this is the head of the Friendbot, now the Friendbot is sort of shaking side to side a bit slowly. So yeah, that's a calm, slow move. Now let's find an excited movement. So we need a short duration for this wave. So maybe anything below 1, so 0.5 maybe.
Okay.
Yeah, so see, now it's like a bit quicker. I would go even a bit quicker because it's even more excited to see you.
What about 0.2?
Yeah, go for it. So now it's like, shaky excited. And okay, so now we know these two numbers, right? 0.2 and 4. And we want to oscillate between them when I touch it. So when I'm not touching it, I want it to be 4. And when I'm touching it, I want it to be 2. Enter the circuit touch. So we're going to use the circuit touch to modulate the length of the wave. So, well, since I said that, let's connect the outlet of the circuit touch to the length of the wave. Okay, cool. So now things stopped for a bit because we're not touching the circuit touch. And now we're gonna play with the minimum and maximum numbers. And we're gonna use these two numbers to control the two behaviors of the wave. So we know that if we're not touching it, so the minimum that represents the not touched, we want a slow movement, and that was 4, right? So you type 4 there. And for the maximum, which is when we're touching the sensor, we want a small number, which is conceptually, the maximum is smaller than the minimum, but it's just representing the two bounds of the circuit. Well, I think you need to click once on that circuit touch for this to start running. This might be some small bug, yeah, in the preview. But now you can see, like, if I'm not touching, if Lindsay is not touching it, it's slow. And the moment she clicks on it, then it becomes quick. Maybe the 0.2 is a little bit too much, Lindsay. Let's put 0.4 in there. And then we can make the 4 even higher, like
okay.
6.
6, you got it.
Okay, so now, and yeah, now we have this like calm movement. And then when you click it, it becomes really quick. And you can clearly see in the wave down there the difference in the movement. So another thing that might happen is that now the final wave is going between 0 and 1, which is the full movement of the servo. And this might make your robot turn too much with the head. So I would sort of modify the minimum and the maximum of the wave so we constrain the movement of the motor a little bit more. So maybe between like 0.4 and 0.8, not on the wave itself. Because the circuit touch is controlling the duration and the wave is controlling the position.
What did you say, 0.4? And what was the other one?
Like, I don't know, 0.8.
8? All right. Oops. That's too much. Always check your code.
Yep. Yeah, it's because if you don't type it quick, it will try to correct it for you. Yes. Okay, cool. So now we have a little bit more, as smaller range for the movement of the motor, which I think should make it for a fun Friendbot. Do you want to maybe upload this code and see what happens?
Yeah, let's do it. Upload our code. Give it a test. This is kind of a nice way to interact. Yeah,
it's fun. Oh, pair programming is super fun. And maybe can you spotlight this video so it becomes bigger?
Yeah, absolutely.
Or maybe you can stop sharing because now we've done our...
Yeah, so I'll stop sharing. So now you can see the final version. Well, maybe not final, but, you know, always see roughly what we've created today.
Yeah, so when it touches Lindsay, it gets really happy. And when she lets it go, it moves slowly.
You can see our little heartbeat. Looks like one of my LEDs is loose, but you can see at least half the heart beating, or at least the best representation we can create for a heartbeat.
Nice.
Wonderful. So I think we have reached the end of our very lengthy but really awesome demonstration. Thank you, Paula, for teaching me some pair programming techniques. I think I can always be better at collaboration over my project, but also learning a lot about these waves. I mean, I think that just alone with using the wave nodes in flow programming, you can do so much. And I mean, it's a lot of great opportunity to really expand and broaden and broaden your experience with coding.
Absolutely. All right, I now back to the Zoom here, and I see we have many questions.
Yeah, and I think just before I switch back, I'm going to just do a quick preview of the screen of the code we just made, just so everyone can see, because I got a question about that. So just give me a second. I'll just flash it for just a moment here. Maybe take screenshots, but of course, as always, at the end of these planars, we try to take screenshots, kind of break it down as a summary of what we've created here with Paulo and my projects, and also the core concepts of what was taught. So don't worry, we will also send an email follow-up with all these resources. So even screenshots of the code, as well as some of the collections of Paulo's brain written best I can represent on slides. All right. So I'm going to stop sharing my screen here and maybe return back to human mode. I actually was the Friendbot. I turned into the Friendbot. Okay. All right. So we have like a couple questions here. I think one of the first questions I heard was actually from Christine, which was, what started flow programming? Where does it originate from?
Yeah, it actually started in the 70s, if I'm not completely wrong, in a Canadian bank software, and it was inspired by some early experiments of IBM, and it sort of took off from there. I need to do a sort of a full, because there is a bit of a gap in my history from this 70s until it starts being used in synthesizers in the 80s, and for networking. I mean, there is a concept called UML that is basically how you represent how systems interact with each other, and it's sort of, boxes that connect to each other. You might have seen this, that represents a flow between things, right? You can go here, then you can reach a block, and then it's like if, then you can point to another one. And this has been around for a long time. I'm not exactly sure, but that's since before the 70s. But in the 70s, it was actually actualized into a programming language. I hope this answers it. Is not that very thorough answer.
Well, that's okay. Maybe we can try to post a short history about the flow programming and the resources.
Yeah, absolutely. That would be.
So how long did it take you to develop this simulator?
Oh, I mean, it's one of those things. Did it take my whole life? But, well, I mean, this is something I always wanted from the release of Quirkbot now a couple of years ago. But technically, it was quite challenging. Throughout this year, I've been actively developing it for a big chunk of my time. So I would say, all in all, like some good 8 months of full-time work to sort of get it to the state it is now. There was many interesting challenges to solve. If we look Quirkbot versus Microbit, they have fundamentally quite different architectures, and and we had to try some different solutions in order to match the code.
And when will we be able to use the virtual simulator? So right now we have like kind of a preview link. When will it be live?
Yes, so this is now under beta test. We are testing it a lot, and obviously exposing it to the wider audience. And the goal is to have this out right before the end of the year. So hopefully you can sort of during the holidays play around with this. But for that to happen, I actually need your help. I need your help in testing and giving feedback. And we need to make sure it's ready for prime time then. If not, it's gonna come out very early next year. I mean, we are quite close to the end here.
And will there be a webinar with the simulator for advanced blocks, like more advanced programming concepts?
Well, if it depends on me, yes, I'm up for it. I'm not controlling the webinar's schedule, but please invite me and I'll come talk about it.
Great. And so Christine has asked also, will we be able to continue using the simulator as beta testers?
Yes, albeit not on that URL. I think, well, if you're interested in giving us a little bit more formal feedback, please connect. Well, maybe you already said you're interested now, but Lindsay, we can do this as a follow-up on the email as well and collect the emails of the people that are interested. And then I can prepare a little bit more formal setting to collect you guys' feedback. But yeah, great to know that you want to be a beta tester.
Absolutely. So I'm going to close off the PLAYINAR, but thank you, Paula, for facilitating this great session. And I think that the answer is yes, we will have another PLAYINAR with Paulo, perhaps exploring more deeply another concept, like maybe we could pick another node and really think about the real world applicability or something in nature as well. So I hope we have you again for advanced programming concepts.
Yeah, absolutely. It's a pleasure to be here, guys. We'll try to answer. If there was more questions in the chat, we can try to answer that asynchronously, which is another concept we could talk about. But amazing. Have a great night, morning, whatever you are. It's evening for us here in Sweden since 3 in the afternoon. So great evening in Lindsay.
Absolutely. So so again, we've recorded this PLAYINAR, so we'll be sending out a follow-up email with all resources and materials, and also that you will be able to replicate this session. And also we'll be sharing our code. So, if you took screenshots, that's perfectly fine, but I will also be sending out a link to our code. The simulator, the visual simulator may not be available right away. It'll be available late or early next year, I should say. So just stay tuned for an email from us, email update with the resources and the recorded video. But thank you everyone for joining us, and see you next time. Maybe see you next year, actually, in fact, for the next PLAYINAR.